Okay, 3311, section M. Okay. Let's go over the syllabus and also how we grade this class, and then some administrative issues if you've got any questions. And then we'll go into the contents for today. Okay. Many of you might have taken my classes before. If you haven't, feel free to call me Jackie. Okay. Other titles are okay too. My office is the Sun Building 2043. Okay. My office hour will be Monday and Wednesday, starting from today, if you got any concern about the course, 3 to 5 p.m., okay, after the class, okay? I can also answer your question quickly after the class. That's fine too, okay? Or by appointments. Okay, I would suggest any advice you want me to give to you early in the class, try to speak to me early rather than later, okay? That's my first advice for the course. Okay, anything you think you can suggest me help you learn, also suggest, okay? The only rule is only one person talking at a time, please. Okay. Course information. Okay, so number one, I will go through the website together with you as well. So go to this particular link. You can also go to eecs.yorkview.ca/course/3311. You can also go to the wiki page. Okay, I'll go over it with you. If you go to that site there, I'll make it a little bit larger for you. Okay. Okay, number one. You wouldn't be logging by default. What you have to do is scroll down to the bottom of the page over here, and then you will see there is a login icon over here. Okay, click on login. For those of you who are officially enrolled, you will be able to. Okay, use your EECS login, by the way. Okay, let me use mine. Okay, once you log in, you can see some other invisible stuff from the public. So, for example, labs. Okay, I'll talk about labs in just a moment. We are section M, so you usually don't have to worry about SVN slides. It's for section Z, okay? But you can also feel free to make reference of them. For those of you who are not enrolled in the class yet, send me an email as soon as you can, and then I will enroll you to both course Moodle and also the course wiki website, so you can get access to the contents. The first due dates for the course will be lab number 0. Approximately next Monday. We'll make the deadline more precise a little bit later. But you should really start doing it already. It's for your benefits to complete it as soon as you can. Okay, for section N, I'll talk about a little more resources for you. Bear with me. Okay, so you can, number one, once you log in, go to labs over here. And then you will see, go to lab 0 over here. You will see the instruction. For those of you who are not enrolled just yet, that's okay. I would suggest write down this link, okay? I will try to make it larger for you so you can get access. It's public. Okay, it's this link over here. Can I possibly make it bigger? Yes, we can. Okay, that's a link. Okay, lab 0. Lab 0 will be submitted for grading. However, it does not count towards the percentage of your course for this term, but it's highly recommended. Complete it as soon as you can. Okay, that's about Lab 0. That's your number one job for this week. If you got any question about Lab 0, feel free to speak to me this afternoon, okay, between 3 and 5 and Wednesday. Okay, let me minimize that. Okay, so now for the wiki site, some second thing you should do is there is a tab called Forum. Click on that and subscribe to it. So all the Q&A for the course will be answered over here. It will be moderated by myself and Professor Ostra from the other section. So ask your question over there. You'll get an official answer. And we'll talk about the grading component for this course in just a moment. Okay, but you can definitely go to dates and grades. I also got a PDF syllabus on the section M Moodle. You can also feel free to refer to it. They're consistent information. Okay. Okay, so now this is kind of like the weekly schedule for your due dates. Okay, you can see for this week, Monday today, you'll be lab 0. Early next week, we will release, or even this week, we'll release lab 1. Okay, and these are the percentages. I'll go over them in just a moment. Let me switch back. Okay, that's a wiki site. You should really go over there as thoroughly as you can early, so to get familiar. Okay, there are 2 Moodle sites, okay? You log into Moodle. One would be just for session N. So you might have already received announcement from me yesterday about class road change. Okay, it's fixed. You can ignore that. Any announcement specific to our section, and I will send through this Moodle, okay? There's another Moodle site that's combined for both sections. We don't really use that often, but if there's any announcement, we want to get to you quickly, so that can also be there. But the bottom line, check your email regularly, okay? Any questions? Okay, if you're not enrolled yet, please send me your name, student number, your passport ID, so I can search for your identity, so I can add you to the wiki site, okay? Do that as soon as you can. There'll be no extension for labs, even if you have not enrolled just yet. There'll be no excuse for that, okay? Let's make it clear. Okay, still attend a lecture if you have not enrolled, and then participates, no extension. Okay, so now, that's lab 0, all right, okay. Course syllabus, I also update something to section and Moodle site. You can check it maybe later today, okay? It's not there just yet, but I will do that. There will be 2 lab tests, one before the reading week, and one a little bit before the end of the semester. There'll be 2 lab tests, programming tests, and you will be required to actually complete some programming and specification tasks on the person lab machines. We'll give you more guidance later, but if you stay in touch with the course pace, you should be okay. But compilation is very important. Okay, so if your code that's submitted does not compile, you're going to get 0. Okay, please get help early. Okay, lab 0. Okay, I will typically try to go to lab session on Friday, so at least for the first hour or half an hour. If you got any questions, feel free to ask me. Okay, if you cannot make it to my office hour. Okay. Study tips. As you can see, I try to record all my lectures throughout the semester, but it's mainly just for you to actually don't really try to miss the class just because I record a lecture. I would suggest use it as like a study guide. Only you don't really want to rewatch the recording every time. It may not be the wise use of your time. The best you can do, come to the class and then try to understand as much as possible. Don't worry about missing any notes I'm writing. Everything I'm saying, I'm writing is recorded. You can definitely refer to them. Okay? And then ask questions. Okay? You can take notes even though that's incomplete. That's fine. Okay? Okay, required study materials. You can, this is a website I want to show you. Okay. Go to www.eecs.yoky.ca/tell.jackie. That's my website. And then go to teaching. I'll show you here. So if you simply go to my homepage over there, that's my homepage. Go to lectures. And then you'll see under lectures, I got 2020 winter, go to 3311. Okay? All the study materials for this section here will be posted here. Okay? I'll try to upload the recording for the lecture on the same day. I'll try. Okay. And then everything can be found in this table. It will be updated as we go. Okay. And for lab 0, so there are 2 tutorial series you're recommended to actually complete. One is about setting up the GitHub for your private repository if you haven't done so in the previous courses. And also to highly recommend it to really go over this a little bit long tutorial videos to go over some basic syntax about the programming language we're going to learn. Okay, this course. Okay, and week 1 is really the time you can invest the most time when you're not so busy with other courses. Take my advice. Okay, okay, go back here. Okay, there are also some assigned readings you can also see from the wiki website. There is a textbook. I didn't really have a hard copy over here, but if you refer to the SVN slides tab, you will see the free copy of it. Okay, it's permitted to this course only. Okay, you can also use it. You don't have to purchase that. There will be some assigned readings, but I would say for this section here, my lecture materials first of all prioritize that, and then if you want to fill in the knowledge gap, you can also read the textbook. Okay, very quick tips. Since you guys are in 3rd year, I don't need to bother you too much, right? I'll just mention a little bit, about general tips about studying CS. Okay, I think hard work is definitely necessary, but it doesn't really guarantee success. I would say the best way, I keep being asked by students, how can I succeed in this course given that we're learning a new language? I would say do your part as early as you can. Don't procrastinate. If you really get stuck, don't get stuck for too long. If you get stuck for more than 1 hour, it might be a sign you talk to Jackie. Okay? Yeah. Okay, you can read it. Okay, I don't want to bother you too much. Okay? But you definitely want to master the ground stuff, which will be the lecture slides my iPad notes, and any example we talk about in the lecture, or any question you guys might ask, my responses, etc. Okay? But it's really important to think about the subject yourself and then ask me questions. That would be the best way to learn. Be curious. Okay? And all of you took 2001 before, right? Do you know what an NFA is? Okay, like a state machine, basically. Yes, good. Okay, so for the benefits of those of you who want to get a little bit more precise guidance, there you go. Okay, I'll go over that with you, all right? It's not going to be on the exam, don't worry. I just want to go over with you quickly how you should study this course, very quickly. I wouldn't waste too much of your time, but just say that in the first lecture. Okay, so now let's say you're here today. This is your starting point today, okay? And then you should really attend lectures, which everybody is doing that. That's pretty good. But try to pay attention, right? If you only check your mobile, that doesn't count, right? And then there will be some tutorials I'm going to record either previously or this semester. Please try to follow them and ask me questions, okay? And now, for the labs over here, there will be 4 labs throughout the semester. If you think about the percentages, they may not occupy so heavy, but I would say they're really important to help you understand the materials. So try to stay being as honest as you can. We do plagiarism check for every lab and the project. So we actually caught quite a few cases last semester. So please don't risk. Just do your learning, ask questions. We are more than happy to help you. Okay? Given that you have done that, so now you reach this point over here. Okay, it's not enough. Okay? What you should do is, you should really, if you really get a little bit stuck, what you should do is maybe try to refer to part of the recording for the lectures. It's recorded for every time. And also, reflection is really important. What do I really mean by reflection? Think about why we're doing things the way we are doing. And every time when I talk about a particular design, before I get to the ultimate solution, I'll always talk about a motivating example and also some bad design to begin with. You want to focus on them. Okay? Okay, and also you can talk to me. Okay, and I would say it should be not surprising you will succeed if you follow all these. Of course, things might happen, right? So if you really fail, then we'll talk early. Okay? Okay, that's my quick advice for you. Okay, academic integrity, please make sure you never share the code for your lab in any way, shape, or form. Okay, never do that. Okay? If you do GitHub, make sure it's private repository. Okay, and then you can read the rest. Okay, if you need any accommodation for the exam or the test, please speak to me as soon as you can. Okay, I will try to see how I can accommodate. That's all the administrative issues. Guys, any questions, please? Yes. Will I show up on Friday for the labs? Yes, I will. Yeah. Yes, your first scheduled lab session will be this Friday, right? But I would suggest the following. Before Friday, you want to really try to complete lab 0 as much as you can. At least you should get to the point you are really stuck, so you can ask me questions on Friday. Okay? Again, this week is your best opportunity to catch up with the course. Once we start giving you lab 1, it's going to be quite intensive. Okay? Yes?
Do you post the slides after the lecture?
Oh, the slides. Yeah, I will try to, yeah. So maybe not for today, but I'll try to post the slides maybe before the lecture. So for those of you who want to write on the iPad or etc., you can do it. Yes. Yeah, I'll try to do it from the second one. Yeah, no problem. Yes? You're saying you only see the section M, but not section M and Z. Maybe you will see that a little bit later. Yeah. Are you just enrolled today, or?
No, a while ago.
A while ago, before the break. You know what? If you don't see the section M and Z, let me know a little bit later. Okay. Yeah. Guys, any questions? Any concern? I think there's one final piece of information I want to go over with you. One final piece. Okay. I want to show you quickly the syllabus. Okay. So that information there is completely consistent with what you will see on the Moodle site. Okay, which I'll update a little bit later tonight. Okay. Course description and also course learning outcomes. I'll try to refer to one of them maybe as we go through the course. If I just go over with you, it's kind of boring for now. You cannot really appreciate that. But that's okay. We'll do that a little bit later. Okay, so the textbook is basically this one here. We'll make it available to you. It's permitted to for this course, so you don't have to purchase that. Okay, and there is another textbook over here. It's called Touch of Class. You also don't have to purchase that because if you log in into your York Library account, you can also get it for free. Okay. There is another textbook over here. I'll show you. Okay, it's a classic one for doing design patterns. Okay, the language they use in the book is C++, but it's also object-oriented, so it will be applicable to this course. We'll talk about a number of design patterns throughout the course. Maybe after the first few weeks, once we talk about contracts, once we talk about inheritance to review. Okay, but we talk about quite a bit of design patterns. We only try to give you a flavor about the design patterns in this course. But if you're interested in learning all the rest of the maybe 40 plus design patterns over there, it might be worth purchasing the textbook. Okay, it's not required. For number 3, only refer to it when you are struggling with drawing design diagrams. I also got some slides for you. I'll make it available later. Okay, yeah. So these are the things you can refer to. Okay, lectures, labs, attendance, lab tests, we talked about them already. I want to show you just a grading scheme quickly, okay? So lab 0 is not going to count it towards your course grades, but it's highly recommended you submit and also get some feedback, okay? Okay, lab 1, lab 2, we got 4 labs, so these are the percentages. Okay, lab 4 will be, I will talk about lab 4 a little bit later. That's quite a challenging one, so that's why rates a little bit higher. Okay, but lab 4 is going to be a preparation for your final projects. So definitely worth investing your efforts for lab 4, okay, and others. So lab test 1 before the reading week, 9%. Lab test 2 after the reading week, maybe about 2 or 3 weeks before the end of the semester. That'll be 10%. I also got the exam. For the exam, it's going to be purely written exam. I'll try to schedule some exam review sessions maybe for you after we finish the semester. Okay, depending on how close the exam is to the last date of the class. We'll see. We'll work it out. Okay. Also, you will see some due dates over here. So that means, again, for this week, we're doing lab 0 and etc. You can also refer to the table. It's consistent with what's on the wiki. Okay, so the topics over here is only tentative. I'll try to go with your guys' pace. If you need to go a little bit faster, I can go faster. If you want me to slow down, I can also slow down. That's not a problem. Okay. I think that's all I want to talk about for administrative issues. Okay. Guys, any questions before I go to the course content? Yes. Lab 4 will be before the projects. You can think about lab 4 is more like a phase 1 for the projects. Okay? Okay, so at least I'll see everybody on Friday, right? In the lab session. I'll be there. Okay. Ask questions. All right. You might have heard about this course is using a different language called IFO. But today, I want to do Java a little bit. To justify why we have chosen IFO as a design language for this course. Because we're in the university, we want to convince you by reasoning. Okay, let's do that. Okay, for today and possibly part of Wednesday, I will try to talk about the idea about design by contracts. This is how I plan to do it. Okay, we'll first of all talk about design in general, language independence issue about design, and then we'll try to see what would be the criteria for a good design, and then we're going to use those criteria to evaluate Java, just by using some small example, and then you will see how inappropriate it might be for Java. But let's not make any prejudice for now, but we'll see. And then we'll move on to the language you're going to use for the course. Okay, I want to give you a little bit convincing argument why we chose IFO rather than using Java. There's a reason for that. Okay, not just because we like it. It's not. Okay, so now the motivation number 1. When you write code, when you are developing software system, you definitely want to catch defects or want to catch bugs. But now the question is, where should you catch it? Okay. So far for the courses you have taken, like 2011, 2030, before this course, all you have been doing is so-called implementation. Okay. What I want to do is, I want to show you this particular development cycle, which is a simplified one, right, to get some idea. So we got something called requirements, we got something called design, which we're going to do for this course, and implementation is basically what you have done so far in 2011, in 2030, and also in the first year. It's just implementation, okay? And then eventually you will have release, to release the product to your clients or to your supervisor, okay? I want to talk about these stages quickly, okay? Okay. Again, you don't have to copy this down, okay? It's going to be made available to you, okay? Just try to see if you can understand as much as you can. Okay, we got 4 stages over here. So we got something called requirements, followed by design, followed by implementation, and followed by release, okay? Basically, this is what you have done so far in 2030 and also 2011. So what's really unique about implementation? That means a lot of ambiguity, contradiction, API, a lot of design decisions have been made for you already. You're quite lucky. You're given something to do right away, rather than thinking about what should be done in the first place, right? That's really the unique feature about this course. In 2030, 2011, you're given the API, the method signature, right? And also, you have to somehow decide to use efficient data structure and algorithm, okay? And also, you got to use JUnit test, right? You learned about that in 2030. We got something very similar to JUnit in this class as well. Okay, it's called ESPEC. You will see that in Lab 0. Okay, I want to talk a little bit about the first 2 phases before implementation. The first one is about requirements. Basically, I will only give you some bullet points, simplified explanation. But if you're interested, you should really take 4312. Okay, it's actually covered there. Okay, not for this course. Okay. Requirement is basically your communication with your potential clients or your customer. Usually, they only tell you what they want by using natural language. It can be English, it can be Chinese, it can be any your mother tongue. Okay? What's really unavoidable for natural language is it can be incomplete, it can be ambiguous, it can be contradicting. Okay, just to give you a quick example. Let's say talk about incompleteness over here. Let's say if your clients simply tell you that I want to have a working payment system. That's all they say. Is that very useful? Not quite. What do you mean by working? And what do you mean payment? Credit card, cash, or whatever, right? So just not complete. So that means there's a huge lack of information that's given in the instruction. So far in your instruction for 2030, I would say it's quite complete. It's not incomplete. Okay? They could be ambiguous over here. Ambiguous simply means it's something that's kind of vague. It's not very clear. It could be interpreted one way, or it also can be interpreted another way. Okay? Let's say, for example, right? I'll just give you a small example. Let's say your client wants you to develop an app. They would say, okay, I want it to work as a web interface, or I want it to work as a deployable on mobile devices. In some ways, it's more like an or, so you're not too sure exactly which one they really want. So this is like an ambiguity. Which one should you do? Right? You can make a decision. The final one is really interesting. That happens very often, contradicting. Because the customer, usually they don't quite know what they really want, even themselves. When they talk to you, it might be very ridiculous. For example, they say, I want my application to be very easy to use. Okay, easiness of user-friendliness. At the same time, they want it to be very secure in the following sense. They want a 4-phase authentication. Number 1, they want to do a face scan. Number 2, they want the fingerprint. Number 3, they want some authentication code to be sent to your mobile and confirm. Number 4, they want you to enter your password again. That's contradicting, isn't it? To being easy to use, right? So this is kind of the thing you want to really resolve before you can ever try to do coding, okay? So these are the 3 characteristics usually for natural language requirements. And what you really need to do is something called elicitation. Again, that's for 4312. Okay, we don't cover that. I just want to bring you to the context. Okay. Okay, what about for this course? For this course, we're going to talk about design, which means we have some reasonably good understanding about what the customers might want, but we want to actually sketch some solution nicely in an elegant way. Okay. So now, like for engineers, you need some blueprints for your design. Okay, we'll talk about the idea about blueprints a little bit later. Okay, and now You may have heard about something called UML, Unified Modeling Language. It's actually one popular language for design. Okay, so they are not really executable, which means they're not really like a code, like a Java code you can execute. So that means you cannot really test. Not being able to test your design is actually very dangerous, because if you only try to justify informally, there's really no guarantee like how things will work. But in this course, we want your design to be executable so that it's testable. Okay, we'll talk about it. Okay. So executability and testability is really important. Okay. Okay, finally, once you have your design and also you have your implementation done, okay, for this course, you do both in the same language called IFO. I will get there a little bit later. Okay. Finally, you want to release or you want to deliver, like you want to submit your lab or your project for grading or for work, right? So now there is something called acceptance, which means the customer have to decide whether your final delivered system really satisfies the goals. Okay, either accept or reject. And now you don't want it to be returned for sure, right? It's a very quick walkthrough of the 4 stages. Any questions? So as I said, for this course, we're going to focus more on the design, maybe a little bit implementation as well, but not as much. We assume you have the knowledge about efficient data structure and algorithm from 2011. But for this class, mainly the design. Okay? But before we can talk about the design, we need to know what a design is, and also what a good design is. What should be the criteria? Okay? We'll get there. Okay, let me go back here. Oh, another question for you. Let's say for you, eventually once you graduate, what you want to do, you might be a contractor or you may be working for somebody else, right? Let's say these are the 4 phases you have to undergo always. If unavoidably there would be a bug, like a defect for your system, when would you hope to catch that? Would you hope to catch that in the release phase by the customer? Or you will hope to catch that in the implementation or earlier? The answer is should be as early as possible. Okay, let me show you some documentation over here. Okay, I also gave you the reference at the bottom here. So there's a white report published by IBM. So I actually did a little bit of empirical research over there. But I'll just show you the most important outcome. How do you interpret this chart? So this chart here basically got all the phases I talked about. Okay, let me just help you read it. Imagine that if you can catch the defects of your system at the design level, let's say the cost is 1 unit. If you caught the defect a little bit later in the implementation phase, it becomes 5 units of cost. It's 5 times more expensive if you caught that later, which means if you didn't care too much about the design, you only pay attention to how you were used to software development in 2030, then you might actually got 5 times more expensive you have to pay, right, than usual, like a 1 unit of price over here. And then if you do it a little later in the integration phase, there'll be 10. And finally, if you only catch the bug, almost like a release phase, that'll be 30 times more expensive. That's not really what you want. The lesson, you want to catch the bug as early as you can. So that's why we want to introduce you to this course over here. Okay, design is really important, number 1. Okay, and then what we want to do is, what should be the choice of design language? To be fair, so far you guys only learn about HTML, JavaScript, Java, and maybe C, right? You took also C course as well. And should they be a good design language though? Before we can make a proper judgment, let's think about what is a design. Let's talk about design. So the next topic will be, what is this course about? Let me talk about it and I'll talk about design. Okay? Design, there are 2 parts of the design. The first part is about architecture. Architecture basically talking about how multiple classes can work together. Okay? There are 2. I will talk about 2 different relationships throughout the course, but basically interrelated modules or classes. Okay? Back in 2030, you can think about there are 2 relations you can do in Java. Either you say class A extends class B, right? Let me talk about it very quickly for you so you can connect. Okay, so we talk about relationships between modules. And when we talk about modules, it's a very general term when we talk about classes, right? So number one is about inheritance. So something like this. Let's say I have class over here. Let's say students. Okay, something over here. And then I have another class which somehow depends on that in a way. I can say maybe TA extends students. Okay, apparently that's inheritance. But now for this course, you have to be used to drawing design diagram because your customer may not just want to read your code to understand your design. They want to see some diagram to actually illustrate the relationship. Okay, I'll just give you some quick example. For inheritance, this is how you can draw. What I will do is I'm going to put the subclass at the bottom. That's usually the convention. So I'm going to say TA over here. Okay. And also I got another class over here called students. And then there's an inheritance, so I'm going to draw like this, like an arrow. Okay. I'll talk about notation a little bit later. Okay. Just give you some example. So this one is inheritance. Another one is somehow quite implicit from what you did in Java, but you learn about it before you learn about inheritance. It's called client supplier. Okay. I'll show it to you. Okay. The second one is called client supplier relation. Client is somebody who's using somebody else's service. Supplier is somebody who's providing a service, right? It's quite straightforward meaning. Okay, client-supplier relation. Okay, example. Let's say I have a class over here. Let's say my app. Okay. Okay, I will fill in a little bit more details a little bit later. Okay. Let's say I have another class over here. Let me call it utilities. Let's say in this particular utilities, I have a method called sort, which is going to take maybe some integer array, and then I'm going to sort it, let's say. Okay. You may declare it as a static or non-static, doesn't matter. Okay. So now utilities apparently is trying to offer some service for any potential caller. So now, how can we establish a client-supply relation between my app and utilities? How can I use this service? In OOP, how can you establish a connection between a user and somebody who provides the service? What should you do? Do you say extends? Apparently you don't, right? Any idea? Yeah, exactly. You want to declare attributes, right? So what I would do is I'm going to say my app, I'm just going to have, let's say, utilities. Let's say util is, as Jordan said, you can create some new instances of it. And then after this, you can definitely say util.sort. You can see conceptually it's not difficult. Basically, you declare attributes of certain type. The type you're trying to declare is a supplier. Okay? So now, this guy over here is so-called the supplier. And you're using this particular supplier under the context of this particular class, and this is called the clients. I got another more detailed example for you a little bit later, but just as a first one. Okay? Again, as I said, you don't really want your customer to read the code to understand your design. You want to present something that's graphical, that's visual. How do we draw this? Okay? This one is slightly trickier, but I'll just do one simple example. The way to do this is like this. First of all, you want to create the two circles for the two classes. So first of all, I would say my app. So this is one class, okay? And then I got another class called utilities, the class name. So now I want to show some relationship between them as opposed to inheritance. So what I will do is I'm going to say there's going to be an arrow over here, like that. But now, what's different from the inheritance relationship is, so now rather than showing just an arrow without any label, for client supplier, you ought to show the name of the supplier. Okay? So now, my app over here is actually using utilities with the name util. So what you would do is you're simply just going to say util. And I have a simple question for you. Okay? Sometimes students might get some confusion. They might simply say, well, if I say the name of the supplier should be util, I should definitely supply its type, right? I might say util is of type utilities. Conceptually, do you think this is necessary? Is it really necessary for me to put this part over here? Okay, some of you might think that's yes, but I would argue the opposite. It's not necessary. The answer, the reason is, notice that we have an arrow over here. So that means the client is always pointing to the supplier. So that means when you only say util over here, it suggests util must be of this type called utilities. So you don't have to mention the type again. Okay? So now the way you draw this is by using just like that. Okay, util will be okay. Okay, just the name of the supplier. Okay? Of course, things might get a little bit more complicated when the utilities might be an array of utilities, might be a binary tree of utility, or it might be some generic parameter, which we'll talk about later, but just to give you some idea. So these are the only two relationships between the classes that we're going to talk about in this course. Well, they should cover almost all the cases in software engineering. Okay? Inheritance versus client supplier. Starting from lab number 3, you get complete freedom about satisfying the design requirements by implementing your own classes, which means unlike 2030, we don't tell you anymore what classes you have to create. You decide on your own what classes you need. You might choose a very poor design where you got a so-called Superman class, one single class doing all. That could be one design, but you don't want to do that. What you really want to do is to decompose the Superman class into a few sub-modules. And how should the sub-module be related together? Inheritance versus client supplier. That's something you want to think about. That's design. Okay. Guys, are we okay? Okay, all right. I'll talk about the diagram a little bit later, okay? Again, I'll try to stay as legible as possible in my iPad writing. If it really becomes unbearable, please let me know, okay? Don't complain just in the course evaluation. That'll be too late, okay? For your personal benefits, let me know as early as you can, okay? Sometimes I even myself, I cannot read my writing, sometimes. Okay, architecture, client supplier versus inheritance, okay? So now, specification. This is really crucial. Whenever you want to specify the purpose of a method or some functionality, you want to be as precise as possible so that they leave no ambiguity, leave no incompleteness, and leave no contradiction. What might be the best approach for this? The answer is math. What branch of math? What you learned in 1090, predicate logic. So one of the prerequisites for this course is 1090 about propositions, predicate logic, but don't worry, I'll try to show you examples to actually review those math, okay? Whenever you talk about specification, you want to specify what each method is supposed to do precisely, okay, with complete details. And we'll show that Java may not have enough mechanism for you to specify this. Even if you can approximate it, it's quite tedious, quite error-prone to do it. I'll show you, okay? Okay, for this course, of course, every time you make your submission for the labs and the projects, we want things to work, okay, for sure. Compile and pass all the test cases, okay? So now, we wouldn't really require to really give the optimal in terms of performance solution. You don't have to, okay? As long as it doesn't run indefinitely with the infinite loop, we are happy, okay, for this course. What we really want to focus on is the design, okay? So now, let's talk about design. What should be the criteria for a good design? Okay, let's talk about it. Before I can talk about the good criteria for good design, we want to talk about components of a design. Okay, let's introduce some term. Now, is Java also a good design language? Oh, by the way, I'm not trying to devalue Java. I like Java personally. However, Java is very suitable for implementation purpose. For design, may not be, for the reason I'm going to explain to you today, and also on Wednesday. Okay, so now let's understand what a good design is. Okay, let's introduce some terminology. Contracts, clients, and supplier. Okay, I'll use a different example for you. Okay. Okay, we talk about what a supplier is. Supplier is simply somebody who implements and provides a service. Let's say microwave, manufacturer for the microwave. Okay, and then clients is like us. We are trying to use a microwave. We don't necessarily have to assemble the internal parts of the microwave. We are the clients. We only use it. Like you drive a car without knowing how to engineer a car, right? It's a user, a client. So now, I'll read it to you. Okay, basically, for us as a user, what's the most important part to guarantee we can get a proper service? Make sure you follow the instruction for the microwave. For example, when you heat something, you should shut the door for the microwave, right? And you should power that on. And also, you shouldn't put something that's explosive to the microwave, right? Things like that, right? Follow the instructions. And on the other hand, for the service provider, the supplier, they assume you actually follow the instruction. And they should guarantee, as long as instructions are followed, they should provide a service. Okay? So you can see somehow there's like an obligation benefits, for each party. They seem to be symmetrical. That's kind of the design principle you should really bear in mind. Okay, we'll get there. We have a matrix for you. Okay, so the clients like us, we don't have to know how to implement the stuff. We're only using it. Okay? Okay, we talk about benefits. We talk about obligations. Okay? Let's try to think about, for the case of microwave, let's fill in this table. Somehow later today, and somehow later throughout the course, we're going to turn these informal terms into executable constructs and testable constructs. Okay? Okay, let's try to see. Basically, I'm going to have two rows for the table. I'm going to have one row for the supplier and one row for the clients. I forgot what the first one is. Let me see. The first one is, okay, the clients. Let's say it's us. We are the microwave user. Given what I have just described so far, what should be the benefits and what should be the obligation for us as the clients? According to this example. Let's talk about obligation. How about that? That might be easier. What would be the obligation for us? Yeah, door is closed and then power on. Don't put anything that's explosive, right? Which means you follow instruction. I agree. What about benefits? Given that we follow instructions.
You don't have to worry about how the microwave works.
Yes, yeah, exactly. You don't have to worry about how it is implemented. Yeah, sure. And what's another benefits?
Just use it and you guarantee you get the...
Exactly. So if I put a lunchbox over there, I don't have to worry about how exactly heat my lunchbox. It will be heated. Yeah. Okay, good. Okay, it's easy as that. Okay, we have done the first row. Benefits is we can obtain a service. For example, heat my lunchbox, and then obligation, I better follow instructions. So now, the question is, for supplier, how should we fill in a row? Would it be something completely different? Or would it be something quite symmetrical? First of all, what would be the benefits for supplier? Would the benefits for the supplier as the same as us as the clients? Or what should that be? Oh, benefits. Are you saying the benefits for supplier would be to provide a service? Not necessarily, right? The best thing, the best blessing for the supplier is you don't have to provide a service and you get paid, right? But it's not never going to happen. Don't worry, it's not going to happen in this course. Okay? Benefits? Exactly. So now here's a very important thing to observe, right? This table here is actually very general, just specific to this microwave example. So the benefits for the supplier is going to make sure the clients, when they call the service, they actually follow the instruction. So me, as a microwave manufacturer, I never have to design a microwave that's so magical. You can heat something explosive when the door is open, when there's no power. I don't have to, right? I can assume. all these so-called preconditions are followed by the clients. Okay, I'll talk about precondition a little bit later. And obligation for the supplier. So now if the client does their part, you better do your part as well. Okay, so that's kind of the table. So maybe in the beginning of the course, every time you want to talk about what should I put as a precondition, what should I put as a postcondition, class invariant, etc. Think about this table here. Think about the obligation versus benefits. Okay, we'll get there. Okay. Any questions about this? Okay. Okay, so there's a contract over here between the two parties. The contract will be violated or breached if either party has done some mistake. Let me give you different scenarios. If the instruction is not followed, who should be blamed? Clients? Supplier? Clients, right? Okay. And let's say somehow the client followed the instruction, but the lunchbox somehow is not heated. Then the clients, there's no fault for the clients because they followed the instruction. So that should be the supplier's fault, right? You can see nothing about programming, okay? I just want to talk about terminology quickly, okay? So after these slides, you may have to do a little bit review before beyond today. You want to understand what a contract is and what a supplier is, what a client is. And then we're going to somehow adapt these terms into programming world, especially object-oriented programming. Okay, we're going to do that. Okay, client, supplier, contract, and OOP. Okay, so now let's talk about a little bit code. Okay, before I move on to my iPad, I just want to show you the code, a very simple code. Okay, and then I'll talk about different issues over there. Okay, let's say we'll talk about microwave. Okay, let's say you got two attributes there. You got on or locked. Okay, the issue of them Boolean. Okay, and then also we got power and locked. They're mutators. You can either power on, power off. You can lock or unlock, okay? And then let's say we have a method here for service called heat. You want to heat up something, okay? So I put as general as possible just object stuff, okay? And now let me just omit the implementation over here, okay? I put in comments. I'll read it to you in case it's not visible to you. I say assume it's on and locked. Also, the stuff over here as a parameter is not explosive, okay? So now, how can we use it? Okay, so now if you want to use the service, do you need inheritance or client-supply relationship? Client-supply relationship, right? Okay. Let's talk about another class called a microwave user. You can see the names of the classes are chosen such that it's quite obvious which one should be the client and which one should be the supplier. But it's not necessarily the case every time, okay? So you want to be really understand what's going on here, okay? Let's say for the microwave user here, we got a main method here, and then we simply create a new instance. So in OOP, it's really important before you can use something or to call a method, you want to create a context objects before you can call the method, right? So you declare microwave m and create a new instance of it. And then somehow you're passing some input. I put a question mark here. Maybe it's read by some external output, external inputs or somewhere. Okay, just objects. I put question mark is unknown. Beyond our control. How about that? And then I will simply say p dot power and p dot lock. Okay. And now finally, I have this last line m dot heat obj. Okay. So now I want to spend more time on this particular method call. So now we have set up everything for you to understand client supplier in the context of OOP. Now we want to consider this particular method call. Okay? The same block of code, the same. Okay? Now, first of all, let's again identify the clients and supplier. We have done that already, but let's do it a second time just to repeat. So now, first of all, this is the so-called context objects. And N is of type microwave. This is the type of the context objects. So that means this is the type of the supplier. And just because M is of type microwave, so we can call some service method on that. So that's why I call it heat, right? That's a supplier. And now, who should be the clients? Basically, whichever class it is, you're trying to call this particular method is the clients. Okay? So now, because we know that microwave user is the class where the supplier object is declared. Is declare and call. Okay, you can see this is where we declare the objects for the supplier, and this is where we use it. Okay, so now we can know very easily. So this class that we're talking about is the clients. Let's get it straight first. Who should be the client and who should be the supplier? Okay, guys, are we okay? Okay. Let me do another thing. Okay, let me just open a new page. Okay, I don't want to make any confusion here because it's really important. Okay, the same two classes. Okay, so now again, clients, supplier. Okay, so now let's focus on this particular code, m.heat objects. Okay, let's talk about different timings. Yes, question.
Supplier's M or supplier's microwave class?
Oh, good question. Oh, you know what? To be more precise, microwave is a supplier type. N is very good. I like it. Good. Precision is important. You can think about over here. Supplier type. Oops, sorry. Of course, what type of service you can call on M depends on the supply type, right? Good. Okay, I want to talk about two timings of calling this method. Before the method call, after the method call, okay? So if you don't mind, let me repeat this particular line over here to here, okay? M.heat obj. Before the method call, it's called a pre-states. Before that, it's called pre-states. After that, it's called a post-states. Pre and post. Sometimes it's called after states. And this is also sometimes called before states. Doesn't matter. I personally prefer pre and post. It's just shorter. Okay, pre and post. Okay. So now it's really important for you to understand. We talk about obligation and benefits for client and supplier. So now we want to talk about in the pre-states versus the post-states. What should be satisfied? Okay. So now let's talk about the pre-states. What should be satisfied? Okay, let me give you a little bit hints. Remember this table over here. Okay, let you focus. Before I call m.heat, what should I satisfy? Should I satisfy follow instructions, or should I satisfy obtain a service? Follow instruction, exactly. So that means before, in the pre-states, the obligation for the clients must be met. Simultaneously, the benefit for the supply must be met at the same time, right? Because they're equivalents. Okay, let me write it down. Okay, I'll put it here. So before this, satisfy will be the obligation. Okay, running out of space. Obligation of the clients. Also, at the same time, the benefits of the supplier. So these are just equivalents. Okay? but it might be talked differently depending on which context you're talking about. Okay, so they should be met. At the moment, are they met? Or you just don't know? We talk about 3 obligations for the clients for heating the microwave, for heating using the microwave. It should be on. Is it satisfied? Is it on, the microwave? Yes, because you call M the power. Okay? Number 1. Yes, check. Number 2, it should be locked. Is it satisfied? Yes. Number 2 here. Now, is it explosive? Is a guarantee is non-explosive? Well, according to the code over here, as soon as we assign the unknown to OBJ, did we ever check whether OBJ is explosive or not? So that means as far as microwave user as a client is concerned, they are not so responsible for the OBJ. They should have checked it before they try to call the method on heat. Okay? So now, non-explosive, I would say no. Because question mark over here, right? I'm talking about the question mark over here, is never checked before the call. Okay, this really is important. So that means before you try to call the method to use the service, you want to make sure all the obligation for you as a client must be met. Okay? Seems like the clients in this particular scenario is not very good. They might be violating contracts. Okay? Okay, let's talk a little bit further. Let's say after this, we also got something called post states. In the post states, oh, by the way, one more thing to say. Okay? So we are not too sure if that's explosive or not. Okay? So on the slides, I said something like this. Okay? By the way, that's exactly what you just said. Okay, nothing has been skipped. Okay? So now we say that we want to make sure it's on and locked. If they are not, it's the client's fault. But in this case, it is. Okay? On the other hand, whether that's explosive or not is also the responsibility for the client. In this case, we just don't know. So it's not guaranteed. Okay? So the client is also not being very responsible. Okay? Okay, so now when it happens to be explosive, it's the client's fault. Okay. So now, in a programming context, if any of the obligation for the client is not met, should we even bother to execute the method? We should not, because if let's say if there's an explosive we are passing to the microwave, we shouldn't even try that, right? Okay, good. That's really important. Okay. So let me make a remark over here. In the pre-state over here, if any obligation of clients not met, do not execute the method. Okay, that's what pre-states. Okay? If we can ever reach this particular state here after the method call, which means the method can be executed and we terminate, that means the initial instruction has been followed and we try to execute the service. So now, we have now shifted the burden to the supplier. Because your client has followed all the instructions and now we have run your service. Is the outcome satisfiable? Okay, so now, in the post state over here, now we know that it should be the obligation of, as opposed to clients, it should be now for the supplier. And also it will be the benefits of the clients. okay, as opposed to supplier, right? You can see it's symmetric. So the lesson learned from this particular illustration here, be in the pre-state and the post-states, you can see the obligation and benefits are completely symmetric, right? Before the method call, client should do more work. And if the pre-state has been all good, now it will be moment of truth for the supplier to make sure they have done the right thing. Both are important, of course. Okay, guys, any question about this? Okay, hopefully by the end of today, you can be so clear about contracts, supplier, and clients. Okay, we haven't talked about exactly what kind of contract we can write. We'll talk about it. Okay, we'll get there. We'll use a different example. Okay. What is a good design? Okay, now that we learned about contracts, the benefits about contract is you can clearly lay out the obligation versus benefits between the two parties. You're being very clear about if there's anything that goes wrong, exactly one party should be blamed. Okay, not both. If something goes wrong and then both parties should be blamed, well, nobody's to be blamed. That's not good, right? Somebody got to be blamed, and this party should be responsible. Okay. So a good design should explicitly and unambiguously describe the contract between client and supplier. So now let's very quick check. We're going to do it precisely this. In Java, how exactly do you lay out the obligation for clients? Java., I agree. But Java., you can definitely say the precondition for this method should be, for example, the y should be positive, for example. Does Java., enforce anything at the runtime, though? Not really. That's not good enough. It can do something, but not satisfactory. Anything else in Java? How can we encode the obligation for clients? Huh? Type check, yeah, just make sure. Well, type check is actually quite, yeah, type check is important. For example, if we're expecting the client to give us a lunchbox, we cannot give them a chair, right? Yeah, but more to it. Exceptions, yes, I agree. We're going to do that. However, exceptions might turn out to be so convoluted, so complicated that you don't want to do it. Okay, we'll see. And how do we actually do not post-condition. How do we do obligation for the supplier? Let's say this. I'm now trying to do a binary search. I'm providing the service of binary search. How are we supposed to somewhere document this kind of like obligation for me as a supplier? Where should we do it? Should we do it inside the method or outside the method? Don't give me an answer just yet. We'll do it together. Okay, think about it. Right? So these are all important issues before you can use a language for design. That's why I want to talk about it first. Okay, okay, obligation versus benefits. Okay, if you can really have such contractual description, it's called a specification. Okay, you got obligation, you got benefits. Okay, so now if you want to conduct software design, you really want to guide your design using contracts. Okay, always think about what's the balance between obligation and benefits. Instruction for clients should not be unreasonable. For example, we should not expect a client to build some microwave from scratch, right? They shouldn't have to fix the microwave. On the other hand, as I said, you shouldn't really expect the supplier to build some magic microwave, right? As I said before. Okay, you want to make sure it's reasonable arrangement between the two parties. Okay, obligation and benefits. Okay, question for you. Okay, let's do a little bit of exercise here. Let's say we have a binary search service. What would be the obligation for a user of the binary search? Obligation. Or it can be any arbitrary array. Would you agree array should be maybe not null? Okay, that's one. It is sorted, yes. So for me, in order for me to use a binary search properly, I cannot just give some randomly ordered array and expect the binary search to work. You can easily miss something, right? That's really important. Okay. It's sorted. Okay, so now if there's a violation, there should be only one. Okay, remember this principle. Later on, we're going to do another example in detail. So to judge to see whether a design is good or bad, when there's something that goes wrong, exactly either client or supplier should be blamed, not both, or neither. Okay, something called design by contracts. So design by contract is not just for iPhone, which we're going to use for this course. You can also do design by contract in Java, which we're going to do from now on, but we're going to see how troublesome it could be. But before we make a judgment, let's see exactly what you should do. All right. So now, for the rest of the class, I got another maybe about 15 minutes. I'll do something, and then I will finish that maybe in the first half on Wednesday. Okay, let's focus on the example. So now, let's say I will give you a problem to solve in Java. Okay, we want to do a little bit of design. And we know that to do the design, you want to clearly lay out the obligation and benefits for the client and supplier. Remember that principle, okay? It's a bank account example here, okay? I got different requirements. Let's say we already got some precise requirements for it. It can be a little bit vague, but let's live with them. Requirement number one, each bank account is associated with the name of the owner, for example, Jim, and an integer balance that's always positive. And now, think to yourself, when you see always positive is a natural language, how can you formulate it using some proposition in 1090? Think about it, okay? That will be beneficial for you. Requirement number two, we may withdraw an integer amount from an account. So here it's a little bit vague. We may or we may not. Under what circumstances should we be able to withdraw? Think about it, okay? We're only going to use requirements 1 and 2 for the example. For 3, 4, and 5, it'll be as an exercise for you. Okay, we're going to talk about 3, 4, and 5 a little bit later in the course. Okay, 1 and 2. Okay. Okay, if you want to play with the Java version, I provided that as a source code. You can download it to play with it, and there will be some setup to be done in Eclipse. I also included some videos for you. You can try. Okay, let's say version 1. We're actually going to go in the following way, as I said. Always, it's not the best way to learn about something, to really go to the ultimate solution right away. It's not the best way. Is to really go for the initial intuitive solution, criticize on that, and try to make gradual improvement. That'll be the best way to learn. Okay, version number 1. I'm going to show you some code. Very easy code. It's not complicated. Okay, I want you to criticize why or why not the design is good, is appropriate. Okay, let's talk about it. Okay, let's say we got account v1 for version 1, and we have string owner. We got integer balance. Okay, and then we got get owner, get balance, very easy. We got a constructor here which will initialize the owner and also initialize the balance, right? Use a this keyword, okay? Very straightforward. And then we got a withdraw method which will simply decrement the amount accordingly. Seems to be okay. And then we got toString, okay, just to print out the account. Would you believe that this design is appropriate? Okay, that's good. It's a good intuition. So now, let me hear about your criticism before I talk about them. At least 3. Anything. Speak out your mind.
So you're not checking for the negative balance?
You're not, can you be a little bit more precise? Okay, tell me first of all which line you're thinking that's problematic.
So I guess it could be on before or the line 10.
Line 10, okay.
You're subtracting without checking to make sure the balance will not go negative.
Okay, yeah, you mean or for example, let's say at the moment, it's actually a very good account deal. Let's say you only got $100. It allows you to withdraw 1 million. I wish to have that kind of account. Okay, number 1. Okay, number one design if defects is you didn't check to see whether the amount is too big with respect to the current balance. Okay, anything? Yes. Oh yeah, it's okay, because remember requirement number 2, we only talk about withdrawal. So the lack of deposit is not an issue here. It could be eventually, right?
Could have somehow opened an account with negative balance.
Yes, I agree. So you're basically talking about line number 7. We are assigning balance to this balance. But what if balance is simply minus 1 million, right? That's not good. Okay, 2. Jordan.
You could deposit in the account by just withdrawing a negative balance.
Yes, that's another amazing thing about this account. I can withdraw minus 1 million,
Yeah, and then
right?
you add
Yeah, exactly. That would be also very nice, but it doesn't happen in real life, right? Okay. Yes, anything else?
Maybe make a deeper copy on the name of the owner and the balance.
Oh, I see. That's a very good point. Even though we wouldn't talk about per se in this example, I'll mention that quickly. So another very good point about this is when you see line number 7, we say this owner is assigned to owner. You create something called aliasing in OOP. So this is quite dangerous because you can easily modify this particular string, which means somebody else will be affected as well. That's what's going to be caused by aliasing. We'll talk about it, okay, a little bit later. Okay, so 3 criticism. Number 1, balance for the initial account can be negative. Balance to withdraw can be negative or too large, right? At least 3, okay? So it's not really a good design, okay? So now what we should do is let's just illustrate very quickly to convince you, and then we'll move on to version number 2, okay? So what I will do is I'll do it quickly for you. Okay, let's say example critique number 1. If I try to create a new account over here to say I want to pass minus 10, okay? So that means I'm going to give minus 10 over here. You can see the client of checking this particular account is not checking to see if the account is actually, the initial balance is actually should be positive, right? So now this is not good. So that means you will simply assign that to minus 10. Okay, that's not good. So after this, you will simply get initial balance minus 10. Okay, so now for the first one, the problem is obligation of the clients, which is the bank app, is not met. So this guy here should be positive. Okay, that's the first scenario. So every time you want to show a design is actually not appropriate, the most straightforward to give proof is by using a counter example to disprove it. Okay, let's do the second one. Okay, quickly. So now you can see now 100 is the initial balance is good. Okay, so check. So now the client has done the right thing to initialize the account. Now, when we try to withdraw, it said withdraw minus 1 million. Okay, according to the current design, it's actually okay. Nothing's going wrong, or nothing's going to be go exceptionally wrong, you know, and at the runtime. So it will simply say this. Okay, that's not good. Because amount of withdrawal is negative. Okay, finally, third critique. Okay, let's say we got 100 here. Again, it's good. And now we try to withdraw 150. It's positive. But now the problem is, when you try to do the withdrawal, you're actually going to get minus 50, right? Again, your application should not just run as normal. It should complain somehow. Okay, that's the critique about version 1. So now what should we do for version 2? Okay, let's at least get to version 2 today, and then the other 3 versions should be done next class. Okay. The problem for version 1 really is when the client is trying to call the service, they have not checked the input condition properly. That's the problem. Okay, so they have not fulfilled the obligation. So the way to encode the obligation for the clients is to specify so-called precondition. Okay, let's do at least a precondition for today. Okay, let me go all the way to the end of version 1. Okay, everything has been illustrated, but I can see more detail in the slides. The way to improve version 1 is by specifying preconditions. Okay, What's really a precondition? Let's define that properly, okay? Precondition is basically like a surface condition. Under what circumstances should you serve the clients? Is this exactly exception? Is it? It sounds similar, right? But not exactly the same. If I say I have a precondition P, can I use this condition P exactly for throwing an exception? Let me make my point more precise, okay? Yeah, bear with me just 5 minutes, okay? Yeah. So now I really want to make it clear to you. Basically, the point before you leave today, I want you to at least have some good idea about the difference between precondition and exception, okay? Precondition versus exception. And exception, you know very well from the previous Java courses, okay? Precondition, again, the best way to think about it is surface condition. And exception is error condition, agree? Under what circumstances should I give an error signal, okay? Okay, let me just give you a very simple example. Let's say I'm trying to do this particular method, let's say double over here, and then divide. And then I got double x and double y. Let's say this. What should be the precondition? I'm talking about under what circumstances should I serve the divide. I'll give you two choices. How about that? Choice number one, y equals 0. Choice number two, y is not equal to 0. First of all, before I say anything else, you can see 1 is equivalent to the logical negation of 2. Agree? Number 1, okay? So now, which one or 2, should be the precondition? 2, very good, intuitively, that's very nice. So this one should be a surface condition, so I only try to do division when y is not equal to 0. So this would be precondition. So my question to you was, can I simply use this verbatim to say over here, if, copy verbatim, y is not equal to 0, and then I'm going to throw illegal argument exception. Is it going to work? Do you think this is appropriate? No, apparently, because somehow I'm mixing the concept about precondition and exception. They are not equivalent to each other, but they are logical negation of each other. Okay? So now, what we're going to do is, when we talk about precondition over here, always think about a surface condition. But in Java, there is no such thing programmatically as precondition. So what we will do to approximate this is to negate conceptually what a precondition should be. So now, for this particular example here, how should we encode the precondition? We're going to say, if y, it is not the case, y is not equal to 0. How about that, right? So that means it's equivalent to, if y is equal to 0, in that case, I'm going to give you illegal argument exception. So this is back to your 10, 20, 30. Guys, any questions? You okay? Okay, before I let you go a little bit earlier today, I want you to, two things to mention. Number one, it's critical for you to complete lab 0. Okay, if you got any questions, drop by my office hour, 3 to 5 p.m. Monday and Wednesday. Number two, before next class, make sure you understand contracts, supplier, clients, and also precondition versus exception. Okay, and then we'll talk about the rest. Okay, see you later. I will do that, yeah, later today.